Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n to the power of 8 minus 625 equals to 0, and we will solve this problem for the values of n. So in this question we find all the roots of this equation, so that the very first thing we are going to do is, here first we rewrite this equation as, we have n to the power of 8 and we write it as n to the power of 4 and its whole squared, minus we have 625, we write it as 25 squared, and it is equals to 0. So in the next step we will use here the nice square identity, and you know about this identity. If we have a squared minus b squared, it is equals to a minus b times of a plus b. And if you focus on this equation, we have this is the value of a and this is the value of b. So now we put these two values in the below formula, so we get the output of this equation in this form. We get n to the power of 4 minus 25 times of n to the power of 4 plus 25 equals to 0. So that here we have two cases. Our first case is to write n to the power of 4 minus 25 equals to 0, and the second case is n to the power of 4 plus 25 equals to 0. So now we solve these two cases one by one. So here I name this as equation number 1 and this as equation number 2. So now first we focus on equation number 1. So here from 1 I can write and we have n to the power of 4 minus 25 equals to 0. So we rewrite this equation as n squared and its whole squared minus 5 square equals to 0. So in the next step we use again this square identity, and according to this one we will apply this formula on this term and we get the output in this form. We have n squared minus 5 times of n squared plus 5 equals to 0. So in the next step we have again two cases. So our first case is to write n square minus 5 equal to 0, and the second case is to write n square plus 5 equals to 0. So in this case we have n square equals to 5, and when we take the square root on both of the sides, then you get here n equals to plus minus square root of 5. So this is the our first two roots of this equation, and now we focus on this one, and here we move this 5 on the right hand side and you get minus 5. And when we take the square root on both of the sides, then you get its output in this form, and we get here our n equals to plus minus square root of 5 times of iota. So these are the other two complex roots of the given equation. So now we find uh, up to 4 roots from the given equation number 1. And now we move towards equation number 2, and we write here from equation number 2. So our equation number 2 will be looks like in this form: n to the power of 4 plus 25 equals to 0. And in this case we move 25 in the right hand side and we get n to the power of 4 equals to minus 25. And when we take square root on both of the sides, then we get its output in this form. So here we have, this is the square root sign, so this implies that the this 2 and square root are gone, and we get here n squared, and in the right hand side we have the negative sign under the square root, so we write it as plus minus the square root of 5, the square root of 25 is 5, and the square root of minus 1 is iota. So here we have again two cases, and we write our first case is n square equals to 5 iota, and the second case is we write n square equals to minus 5 iota. And now in order to find the values of n, here we need to take again square root on both of the sides in this form, so that you will get here these 2 and square root are gone, and we have n equals to plus minus square root of 5 into, we write this iota as iota to the power of 1 over 2. And similarly in this case these are gone, and we get here n equals to, we have square root of 5 into, we write iota, the square root of iota as iota to the power of 1 over 2, and we have again minus sign under the square root, and we write it as iota. So now we need to take little bit simplifications here, and we move towards the final answer of this problem. So we get here square root of 5, and now we add the exponents of these two iotas, and we get here iota to the power of 1 over 2 plus 1, and finally we got square root of 5 into iota to the power of 3 over 2. And here we write the plus minus sign, because here we need to take the square root on both of the sides. So when you take square on both of the sides, then you will write plus minus sign. So from equation number 2 we get the 4 complex roots, and these roots are square root of 5 into iota to the power of 1 over 2, and here you get plus minus square root of 5 into iota to the power of 3 over 2. So these are the 4 complex roots of the given equation, and here we will write these are the 2 complex roots, and these are the 2 other complex roots. So because our question statement is of 8th order, so it means that this question has 8 roots. So here we find the 8 roots are in this form. So these are the 2 and 2, 4, and these are the 4 roots. So this will become total 8 roots, and this is our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.